I started as a civil engineer, and as I was going through my civil engineering degree, I found that I was not particularly interested in building buildings or bridges, but there's a whole stream of civil engineering that has to do with water supply and wastewater treatment, building dams, and then that has turned into soil contamination, and that stuff got me really interested. So by the end of my degree, I was really specializing more on the environmental side of civil engineering. And then I did a master's degree looking at wastewater and phosphorus removal. So phosphorus was a big nutrient of concern back when I was in grad school. It is again in some locations. And then I took a job at Environment Canada thinking that it would just be, who knows, temporary or just, try it out. And it was dealing with air pollution, something I didn't appreciate when I first came into this field. I thought, something gets emitted and then it's in the air and that's it. But it turns out there's so many factors that are interplaying with each other. So people often talk about air quality and air pollution as if they're the same thing, but they're not. Air pollution contributes to air quality with pollutants that are emitted into the air, but some pollutants are emitted into the air and don't have any effect on air quality, certainly not at the levels we see in the atmosphere, like carbon dioxide. But carbon dioxide is an important greenhouse gas, so has huge climate impacts. And so that's how air quality and climate are interconnected, is through this common set of emissions into air that affect both issues. For example, to electrify the vehicle fleet that's on the roads is going to have positive impacts for air quality, because it's not because the CO2 is reduced, but because the other pollutants are reduced, that is going to be helping air quality as well. And then there are a bunch of feedbacks that happen between the two issues. So if we have a warming atmosphere and higher temperatures because of climate change, that increases the rate of reactions that create smog pollutants, even if the emissions stay the same. So yeah, there are emissions, but even the way that you emit into the atmosphere has an effect on how far it spreads and how quickly. We typically will divide them, first of all, into two very broad categories. One is natural, so volcanic emissions, soil emissions can release different pollutants. Forest fires, which we used to consider a natural source, but now because of human impacts on climate, they're becoming a mixed natural and human source. So there's the natural, and then there are what we call anthropogenic sources. So these are the human-caused sources. So we typically think of combustion, so vehicle tailpipes, fuel combustion for heating, oil, wood, natural gas, that sort of thing. But then there are all kinds of other sources of pollutants that maybe have less attention. Or less, they're less well known by the public. So things like the pesticides that you use, there is a portion of them that gets into the air and they become air pollutants. The different solvents or spray paints that industries use will release a portion of whatever is used into the atmosphere. And then there's all kinds of physics and chemistry happening in the atmosphere. Whether it's sunny or nighttime will have a very big effect on the chemistry of how a pollutant changes in the atmosphere. If it's raining, some pollutants are soluble and they get what we call washed out by falling rain. And then there's also the chemical interactions between the different pollutants in the mixture. So understanding air quality, it's too much for any one person to become an expert in. So that's why we tend to have our niche expertise, but we have to talk to each other as well, because we are all reliant on the pieces of the puzzle that other people are generating for us. And now we're starting to pay attention to, well, what happens when all of them are mixed together? Is the toxicity of those different pollutants just added up? Or are there effects that make one pollutant affect another? It's really important to monitor air quality levels there for really two major reasons. One is to know what's in the air and therefore be able to determine if there's a risk to health, whether it's human health or environmental health, ecosystems or different wildlife. The other is to try to understand what the sources are. If you determine that there is a concern because a pollutant is at a certain level that is concerning, you need to figure out where it's coming from if you want to be able to do something about it. And so I started to focus more on air toxics and that whole range of pollutants that's associated with really serious adverse effects like cancer, like reproductive effects, neurological impairments. And then that has evolved now into looking at urban air. So most Canadians actually live in cities. About 80% of Canadians live in cities. And we're exposed to a really complex mixture of air pollutants. Then I also do chemical transport modeling. So when I was first working on polycyclic aromatic compounds, they're trace contaminants, so they're very hard to detect. We just were never able to detect enough of it because the chemical processes that we had available to us, or the technologies, weren't developed enough yet. And so I sort of shifted gears and said, well, with our existing knowledge, if we incorporated these pollutants for the first time into one of these chemical transport models, would our guesses be correct? And if not, how usually you can tell how wrong they are or when they're wrong, or, and that gives you hints about how to correct them. So I do that kind of modeling as well. And so originally the goal was to develop what's called an emissions inventory. So just to know what's being emitted everywhere on a grid, right? Like, as fine as 2.5 kilometers, what we're currently doing. And we're driving that down to 250 meters to get really, really specific neighborhood level, street level even, urban information. As we're finding that, from neighborhood to neighborhood in a city, you can have quite different pollution levels, right? And so we needed to develop the emissions inventory. We needed to piggyback onto that weather model. So to get all the chemistry of our pollutants in there. So how quickly it reacts in the sunlight, how quickly it gets dissolved when rain falls. So then we had a functioning model that allowed us to produce maps. But we've also found ways to use it to answer policy relevant questions, like what happens if you're trying to estimate how much of those come from vehicles? It's not the same as what's in your emissions. It's different because by the time things mix in the atmosphere and react with different pollutants, there's way more to react with in a city than there is in other locations. And so you get a different answer. So we were able to use our model for that. And we've most recently been using it for health studies. So we just published the first of our studies on this, using our maps as an estimate of exposure against breast cancer data. And we were able to see a relationship between the exposure of women, premenopausal breast cancer, in Canadian data. The combination of doing science that is generating new information and then combining that with solving a real world problem. Pollution is a problem that many, many people are concerned about. At the global level, we're now talking about what's called the triple planetary crisis, right? So it's climate, biodiversity, and pollution is the third one. And so working on such an important problem is something that really drives me and gives me energy when I'm coming to work. And the idea that I can be here in a government institution where my work has a direct impact. I have that conduit to pass along my findings and also to direct the research that I do to make it as relevant and as credible as possible. For me, really, it adds something to my work that I don't think I would get if I were working. I could have a similar profession working in the private sector or somewhere else, but I wouldn't be driven the way I am here.